that is the work, joint work with Anton Zabrodin. My apology for those who heard this talk.
There's this small black thing there. Yes.
Okay. Before I come to that object and explain what it means, although this is a title from Wikipedia, I would like to start from
The big one.
oh, there is a delay. From classical problem of complex analysis, known as Fekete problem, 1923. It's a following problem. Suppose I have a complex plane. This is my complex plane. I draw a simple domain and would like to map it to a unit disk. Formula is written in the convention that I map exterior to exterior of a unit disk. So this map, I call it f of z. That's a z plane. That's maybe this w plane. So it's a conformal map of exterior to exterior. So the Riemann mapping theorem says that such map always exists. It doesn't say how to construct it. So Fekete problem, closely related to the subject which Sasha Bagan told us, is an effective way to construct a map. And this is how people construct maps numerically. The story is the following. Let me explain. Consider if that's a boundary of my domain, and I put the endpoints, 1, 2, 3 endpoints, right on the boundary. The coordinates, complex coordinates is xi. All this xi belong to the curve gamma, which is the boundary of the domain. And then I ask for a minimum, for a position of these bits, such that they realize a minimum of Coulomb energy. Those points are called Fekete points. They basically solution of this equation, which is a variation of this functional, under condition that all of them belong to a curve. So those points are called Fekete points. It's almost impossible to study, to find them for arbitrary curve, but computer can do this.
Like Monte Carlo or something?
Monte Carlo can do this, or any electrostatic experiment can do this. Right? So it's a bits, charge bits on this wire. They repulse, but their space is limited. It's a compact space. So they repulse, but there's no space to run away. So they concentrate it usually on curves segments and less on flat segments. It's a typical representation. Okay. Once these points are found, we may consider a polynomial which roots are Fekete points. Pick 1 over n power of it, send n to infinity, and that would be the convergence n to infinity is uniform, and that will be conformal map. Ivan, can I ask your attention, because I need only 5 minutes when you see how the problem is posed, and then So that story is also called finite dimensional approximation of conformal maps. Right? A curve approximated by points, a map approximated by polynomial, and the limit, these points form continuous distribution, which is a curve. Their support becomes a curve, and